So here's an example similar to the last one. That actually appears in the Rogowski number 28 on page 404, but I'm not assigning it. So like this could be very much a standalone problem. So it's another example of, like ln x, inverse sine is something that I know the derivative of, but I don't know the antiderivative of. So another way to look at what the method of parts does is it allows you to rewrite an antiderivative in terms of a derivative. So what I'll do is I'll use the inverse sine of x to be the thing that I want to take the derivative of. So that's going to be u. And then my dv is going to be just 1 dx. All right, so when I lay out my chart, I'm going to say u equals inverse sine of x. du we'll figure out. V we'll figure out. dv is going to be 1 dx, or obviously you could just put dx. All right, so then the antiderivative of a 1 is x. The derivative of inverse sine, I can get off my nifty chart, and it is 1 over the square root of 1 minus x squared. So this is something that sort of, like, it looks like it's not getting any better by doing that derivative, but actually it is, and you'll see why. So then, when I go to write my integral of inverse sine of x dx, and if I think of my integration by parts formula as being the integral of u dv is equal to uv minus the integral of v du, so that means I'm going to have uv is going to be inverse sine of x times x. I'm going to put the x first. It just is a little easier to write that way. Minus, and then I'm going to have integral of v du, x 1 over square root 1 minus x squared dx. Now, how is this any better to integrate than that was? It's totally better. It's completely better. Why is it better? That's a question you should think about while I rewrite this integral with the x in the top. Actually, it's probably not helpful for me to rewrite it with the x in the top, because I can write this like this: x inverse sine x minus the integral of x times 1 minus x squared to the negative 1/2 power dx, right? Now see how I've made it easier? Because now I can use substitution, where this is u and this is a linear multiple of du, so I'm going to call it du-ish. So now I'm going to use substitution instead of parts. By substitution, my method is to say the u is equal to 1 minus x squared, the du is equal to negative 2x dx. I want just x dx, so I'm going to make negative 1/2 du equals x dx. So this is a great example of combining all the techniques that I know, which is really what you want to be able to do with these. So now I can just rewrite using the substitution. So I'm going to bring down my x inverse sine of x, making sure that every line is complete, correct, and clear. I am going to take the minus 1/2 that goes with the du, so I'm going to substitute the x dx with negative 1/2 du. I'm going to take that negative 1/2 and put it out right away, combining this negative with this negative to get positive 1/2. All right, and then integral of, so this is my part of my du, this is my u, so I have u to the negative 1/2 du. All right, see how that worked? So the u, the 1 minus x squared is here. The x dx became negative 1/2 du, right? X dx, negative 1/2 du. The negative 1/2 combines with the negative positive 1/2. Right, then I can do that one by the power rule for antiderivatives. So this is going to be plus 1/2. So I'm going to raise the exponent 1, u to the 1/2 power over 1/2. I've now done all the antidifferentiation, so I have to put the plus c now. And now I just simplify it. I got x inverse sine of x plus 1/2. Oh, the 1/2s cancel out, don't they? So I don't need a 1/2. I'm just going to go sub my u back. My u is 1 minus x squared. I have it to the 1/2 power. So let's just write it square root of 1 minus x squared plus c. There you go. I'm going to rewrite it just because I have a scribble. X inverse sine of x plus square root 1 minus x squared plus c. So that's using parts followed by substitution to find out that the antiderivative of inverse sine is x inverse sine x plus square root 1 minus x squared plus c. Is it going to help you to memorize that? No. What will be helpful is if you want to do the antiderivative of something that you know the derivative of, use parts to rewrite it and then see what you can do next.